the difference in approach that AI enables chip designers to do. And that's why this shortage of electrical engineers is just so much part of why we need to move to full AI capability, as I described.
Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work, episode 362. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. Our community is growing. If you haven't yet subscribed to our weekly newsletter, do it. It's full of additional fun facts and some clips that don't always make it into the weekly show. There'll be a link to subscribe in today's show notes. We are all in this together. If you enjoyed today's episode or any other, you have an obligation to share it with at least one friend. They will know that you care about using AI to make humans better. And if someone you know shared this with you, pay it forward. Tell them thanks and invite someone else to be part of our community, which is now up over 1 million listeners. Thank you so much to our loyal listeners. As always, if you leave a comment, I may share it in an upcoming episode, like this one from Tina in Santa Monica, California, who is a roboticist. Tina's favorite episode is number 301 with William Osman, one of my favorites. Prolific YouTube creator whose insane science and engineering videos have been viewed more than 500 million times, all about the future of creativity. We'll share a link to that one in the show notes. We learn from AI thought leaders weekly on the show. The added bonus, of course, you get one AI fun fact. Here it is for today. John Marshall writes in Web Pro News that more than 200 prominent figures, including Nobel laureates and AI pioneers, issued a stark warning about the perils of unchecked artificial intelligence development at the recent UN General Assembly in New York. The open letter calls for the establishment of international red lines to curb AI's most dangerous applications by the end of 2026. Signatories argue that without enforceable boundaries, AI could exacerbate risks like engineered pandemics, widespread disinformation, and autonomous weapons systems that operate beyond human control. Geoffrey Hinton, who many say is the godfather of AI, who resigned from Google famously in 2023 to speak freely on these dangers, is among the key endorsers. The letter emphasizes that current voluntary commitments from companies are insufficient, urging governments to create verifiable thresholds that all AI providers must adhere to. Of course, we'll link to the full article in the show notes. My commentary: we can and must enforce responsible use of AI without constraining innovation that is possible. Let's not politicize this issue. Today's debate should be centered on catastrophic risk, but also it should go beyond that. That topic is just too easy to dismiss as prematurely optimizing for too many unknowns. Instead, we should spend an equal amount of time focusing AI safety discussions on requiring every technology company using AI to be responsible for the downstream unintended impact on users of automated decisions that are being made today, right now as we record this. As a community, let's stop focusing on what could go right and instead safeguard against all the things that could go wrong right now. Here are the 3 tenets of the pledge I ask every company to take. We'll only deploy AI in production that is transparent, predictable, and configurable. In other words, users must know when automated decisions are made on their behalf. The same user data must reliably result in the same AI output. And when AI makes mistakes, the decision-making process must be adjustable to correct those errors. This simple set of 3 tenets is enforceable, immediately valuable, and will create a culture of AI risk awareness that doesn't require government intervention. We must still prepare for potential catastrophic outcomes that may pose real risk soon, but in a responsible way that doesn't distract us from protecting humans now, while adoption of AI is still relatively low. Now, shifting to this week's great conversation, Faraj Aalaei is a 40-year veteran of the communications and networking industries, who is currently the founder and CEO at Cognichip, an AI company developing the world's first artificial chip intelligence, or ACI, to design semiconductors using AI. He has raised several $100 million for semiconductor companies and taken two previous startups, Centillium and Aquantia, through IPOs. His last IPO, Aquantia, was acquired by Marvell Semiconductors. Prior to joining Marvell and Aquantia, Faraj was the co-founder and CEO of Centillium. Under his leadership, the company went public on the NASDAQ in 3 years, the fastest ever for a semiconductor company. Faraj holds an honorary degree of Doctor of Engineering from Wentworth Institute of Technology, where he also received his bachelor's degree in electrical engineering. He has an MSEE from the University of Massachusetts and also an MBA from the University of New Hampshire. Go Wildcats. And without further ado, Faraj, I've been looking forward to this one. It's my pleasure to welcome you to AI in the Future of Work. Let's get started by having you share a bit more about that illustrious background and how you got into the space.
Well, first of all, Dan, thank you for having me. It's a pleasure to be here and have this conversation going with you. Well, there's a way of background. I arrived in America in 1978 as a 17-year-old kid, finishing high school here and going after an engineering education in Boston area. And that's why you have the list of universities back there. And so in addition to obviously studying electrical engineering and then business school, working in companies like after graduation in companies like Maycom, Bell Labs, AT&T Bell Labs at the time, 10 years and so on. I took a crack at entrepreneurship, frankly, at a very early age. And when I was 19 years old, I started a rental car company from all things by borrowing money from friends. And it's a little bit of thing that people don't see in my resume, which ended up in a total disaster because it was driven by my own myopic view about what was needed. As a student, I couldn't rent a car because I didn't have a credit card. And so I had this idea, what about having a rental car company that doesn't need credit card? So I went and bought a whole bunch of used cars with collecting money from friends who would lend me. And what we learned was the toughest lesson at that young age is that people can just take those cars and never bring them back and leave them up in any of the New England states. And, pretty soon it was all over. So I learned the value of really looking at not just what the need is, but how do you deliver a service? How do you deliver a product that actually can be a wise business decision? But anyway, so that was sort of like early part of my life. And I started my first venture-backed company in 1997, Centillium, as you said. Took that one public in 3 years, and I ran as a public company for another 8 years after that. Then I did Quantia Corporation, which was developing semiconductor chips for data center. And we could see that the speed for data centers increasing. So we took a risk in that area and was paid off quite well, and took that company public, this time on New York Stock Exchange. And as you said, we merged it eventually with Marvell Semiconductors. I went on for 3 or 4 years running my own venture fund, investing in seed and pre-seed stage startups. That was the process by which I learned from other entrepreneurs about generative AI and what was coming. I was making some investments in that area. And the notion of Cognichip really kind of came together at that time, in essentially late fall of 2023. The pain points of semiconductor companies has always been, for the last 20 some odd years, has been increasingly the cost of doing semiconductor chips is just getting out of hand. And one of the reasons for that is that complexity requires a lot more engineers to be involved for a longer period of time. It takes very long time to make these chips, sometimes about 3 years or so before you actually can provide the first sample. And it costs a lot of money. And so we saw after the 2000s, the VCs essentially ran away from investing in semiconductors because they were better alternative for return on capital for them. And so in 2015, I made a presentation to my colleagues, other CEOs in the semi, that that this is an issue that we need to deal with, because if you don't have enough startups creating new technologies, it actually hurts the small and large companies, and in particular the entrepreneurs that are trying to get done. So I had dealt with this issue, discussed with colleagues. In 2023, as I was learning about Gen AI, the light went on that if I could use generative AI to solve these two elements, which was time and cost of developing chips, then I could actually create massive change in the industry that I know and love. And as I looked into that, I found out there is a third rail to this whole thing, in that, according to Forbes and others, we're going to be about 1 million electrical engineers short by early 2030s to keep the pace of growth of the semiconductor industry. And you look further down into that, and you see that there has been a massive reduction in the number of students that actually go to college to study electrical engineering, which is a discipline that's required really for chip design. And we only matriculate about 100,000 a year, which means a quarter of those 25,000 a year graduate. So you can easily see we're never going to catch up with the resources we need to actually grow this industry and respond to the demand. And then, of course, you have the macro level, political and geopolitical issues. So the time was right, and the opportunity had come up with the onset of generative AI to really solve this problem for entrepreneurs and large companies and our industry as a whole, and to some extent, frankly, national sovereignty of this very critical technology. So here I am, a year and a half into it.
Faraj, you just earned the dubious distinction of being the only person on the planet who can credibly say that it's easier to design semiconductors than it is to rent cars. Congratulations. So you've had such an amazing run in the industry. I have so many questions about things you've seen and learned, starting back in the late 90s when you started Centillium, fast forward to today. How has the semiconductor industry evolved?
Yeah, so it's been a steadily growing industry. If you look at sort of like the output, essentially, it is now over 600 billion. It's closing in on $1 trillion in the next few years in terms of the output. If you look at that CAGR, that growth rate of semiconductor industry, and then you follow and look at the CAGR of growth of the resources that we've had to put to create that, they're almost like on top of each other. Every year, the CAGR has been like 6 or 7% during this period for the top line growth as well as the resource growth. And that's really kind of one of the fundamental issues I talked about, is that those resources are just not going to be available anymore if we stick with the way we've been doing things. Now, the way we've been doing things in the last 30 years has served us well. It's gotten us to where we are. But if you project forward, given the other issues that are going on, is that the same recipe is not sustainable in my perspective. So what we need to do is to be able to enable a whole host of other folks that have an ambition and a thought about building a certain device that performs a certain function and do it economically and do it in a shorter period of time. If you think about then what's been happening with the application side of things, you look at ChatGPT or any of these other technologies that are coming along, these applications that are coming along, they scale from 0 to 100 million, sometimes in days, sometimes in weeks. And what we forget is that the underlying technology, which is a semiconductor technology that's allowing that app to be performed, is actually at least 6 years old, right? So the semi industry is trailing the applications by 6-7 years. And what that brings with it is an inefficiency in the way that I'm sure we've all heard, hey, the growth of this AI requires a lot of data centers, requires a lot of energy. We don't have that energy. We got to go build these things near dams and so on and so forth. And a lot of that has to do with the technologies that we use to deliver that application. If you build more bespoke chips in a more timely fashion, then you can actually help save a lot of that wasted energy within the infrastructure that we're building to support these applications as they come along.
I got to imagine that the shift to the internet, maybe in the early 2000s, then maybe in the next decade-ish, the shift to cloud computing, and then there are been other shifts, certainly, but fast forward, now the shift to AI workloads have fundamentally changed the job that chips do.
Yeah, it absolutely has. And we to some extent, I think what the chip folks are using or are thinking about is also the same thing, is that we can't continue to build these bigger and bigger chips and not be paying attention to how those chips match to the applications that we're developing. One of the inside secrets of chip companies is that, knowing that it takes us 5 to 6 years to get a chip into production. And if I'm sitting here as a chip designer, as an architect, and I'm deciding, okay, this is a 5-year, 6-year journey, what do I put in this chip? Well, none of us can see that clearly 6 years into the future. So what we do is being engineers, we use our intuition to say, well, maybe I need to put a little bit more of this in here, even though it's not a requirement today, but it might be. A little bit of that in there. It's not a requirement today, but it might be. Essentially building insurance within our devices. And because devices are so expensive to build, we try to make them multi-purpose. Multifunctional, multi-purpose. Well, that comes with a penalty, right? And we're willing to make that penalty because that's the real life we live, right? It requires, again, a lot of capital, a lot of people. And if you're going to do it, and it's going to take you so long to do it, you might as well do it with some of this insurance policy built in, some of this general purposeful built in. But imagine if you could use compute, the very same compute that's enabled Gen AI, and use that to close this virtual circle. You don't need to make those compromises, and you can build more bespoke, functionally oriented devices within the time horizon that you can see as an engineer, as an architect, or as a product developer, right? You start to change the equation, and with it comes more efficiency, comes more projects that can get funded, and frankly, more development, chip development projects that can be done. Because now they don't necessarily need to all be done with all electrical engineers. We can turn computer scientists who think about these applications into folks who actually define a chip with the help of, computer-based, essentially compute-based designers, virtual designers, which is what, our company is focused on. Cognichip is really focused on creating, if you will, virtual design engineers, chip design engineers that work hand in hand with architects and product planners, so product developers, to create these next generation of chips faster, cheaper, and more to the point.
As you envisioned Cognichip, how much do you think we could compress that, call it, you've been saying 6 to 7 years cycle to develop new chips? How much better can we do it with AI-driven chip design?
I believe that it's very possible in the very near future that we can bring it from years into months and compact that whole thing on initial designs. And if you have incremental designs, of course, it can be a lot quicker. The process of chip development itself can be shrunk significantly because, think about it, Dan. So, in a chip development world, a lot of people who are not chip people, this might be interesting to you, is that we have multiple stages that we go through, architectural design, then we do microarchitecture, then we actually do the design, then we verify that design. Each one of these steps are a handoff from the previous to you. Each one assumes that the previous step was done properly and correctly. But if your development is stretching over a 3-year period as a result of this, every time you make an error, you got to go back to the beginning and keep going, right? To optimize your design. And that's what makes it lengthy, and that's what makes it expensive. Now, if you took that world, that process, and you brought it inside, just imagine yourself now inside a computer cluster. And it's the computers that are actually taking what you want to design with your requirements and creating the work result, right? They can do all of this optimization almost simultaneously. And what you need is more compute, scaling up your compute to be able to handle this. Now, a part and parcel of that, of doing that right and doing it responsibly, is the three principles that you actually discussed at the beginning of this podcast. The approach that we're taking is that we're not creating new languages that only computers understand. We want to do this in a way that at every step of the way, a human engineer can look at the code that's being created, look at the plan that the computer is actually executing, and allow you to accept or reject it, audit it, blow it away, replace it by your own piece, or ask it to do it differently. Where human beings, human designers and architects are in charge. And the computer really is using its vast resources of compute and intelligence and memory to be able to do what it is that you want them to do, right? So, and part and parcel of the way we're approaching this is that, in fact, it's a human interface at all time, speaking normal language to the computer and getting results back, which then you approve to move on and go build your chip. And we think that's very critical because it is so easy to say, oh, well, you know, what the way it's done today, the language and this and that gets in the way. But it is not getting in the way. It is the way. We just need computers to help us to scale it, reduce the time where the function is being done so we can go on and do other stuff.
So you're talking to a lot of AI enthusiasts who actively use AI, who are very well aware of the fact that the ultimate irony of AI is that, while it can get a gold medal in the Math Olympiad, which it does frequently, it can't cook an omelet. And so, when we think about, I like the way you described the role of AI, that human electrical engineers are partnering with the AI to design chips faster. But you also said something interesting earlier, that we're on track to be somewhere, a million electrical engineers short of being able to keep up with demand. Talk me through, how does the Cognichip interactive design process mitigate the need for as many electrical engineers, given that it sounds like it will very much continue to be a human-controlled process, just accelerated by AI?
Yeah. So chip design, just to start with, it's a very, very complex. I've been in the chip design side of things for the last 27 years, and it blows my mind when I look at the stuff that we have to do. Imagine you have, 100 billion transistors, each the size of multiple atoms, that have to be organized in the proper way without failure. What people talk about hallucination, and so on and so forth. We cannot afford hallucination in our line of work, right? Because these transistors all have to come together, do a certain function. They have a physical property that you have to kind of manage throughout the whole process, right? Now, when you're talking about 100 billion transistors and how you organize and how you arrange them to do a function, we cannot expect engineers to keep up with that much stuff in their mind. But human being, also, the way we approach design is we try to understand the requirements we're dealing with, and we head in a certain direction or two or three, and we choose from those. And every time we make one of those choices, we essentially are kind of taking a path to the finish line, right? And coming back and changing is very costly. And human being in its mind kind of figures those things out, right? Now, imagine if I could launch 100 different possible paths to get the solution, right? And use the human involvement to select the best of them. And how do we do that? We do that by setting the criteria for what it is that we're looking for, right? And if those 100 paths that get launched don't really get to within the circle of acceptance that we want, we don't even have to look at them, but we know that they've been explored, right? And so human beings get to participate in that decision criteria and moving forward. And if you are an engineer that used to 20 years ago or 10 years ago go into these files and read every one of those lines and waste your time picking from it, now the computer picks for you. And what you can do is you can elevate to an architectural level. You can elevate to the point of making selections among a few good candidates, as opposed to wasting 3 months understanding every one of those candidates, and most of them you have to throw away anyways because you're not fast enough to understand that they're not converging. And I don't know if that answers your question, but that's sort of like the difference in approach that AI enables chip designers to do, and that's why this shortage of electrical engineers is just so much part of why we need to move to full AI capability, as I described.
Because fewer electrical engineers can produce more output faster.
Absolutely.
With the aid of automated testing and simulations, that sort of thing.
Exactly. Yeah, these systems have within them ability to simulate any of those logical paths that it kind of sets off, and it could do it at the speed of compute, not at the speed of human being, and it can try to reach the results that you set out for it. And if it meets those criteria, it presents it to you as a potential for you to approve or reject.
Now, I envision, this may be a naive question, but I'm going to ask it anyway, that a lot of the work of chip design is the electrical engineer simulating in a lab or doing the work that involves physical material science, testing things like heat transfer and power consumption. You mentioned transistor density, things that require empirical observations and monitoring. And I would imagine that that's a lot of the complexity and the time that's required in getting chips to market. I just volunteer those three, but those don't seem like they'd be as good a fit for AI-driven design. So is it the case that just certain parts of the process are better suited for AI and others can't be automated, or am I wrong in that?
No, actually, you're absolutely right. Because every time you deal with building something physical, chips are substances, right? We can touch them, we can feel them, and chip design is the process that I was talking about. Well, once the design phase is complete, you have to go build samples of these things. You got to bring them into the lab. You got to plug them into a socket. You got to, for lack of a better way to describe it, you have to hold a heat gun to it and see how it does in cold and in hot and, over extreme temperatures. And a lot of that obviously can be aided by AI to crunch the data that you're preparing for it. But it really requires hands-on human being, electrical engineers that understand mechanical, thermal fluid type engineers to understand and analyze these things. They can all be aided by AI. But we need human being in this process along the way. And our belief is you need human being also in this design process, except you just may not need to bog them down in doing these types of work that computers can do better. I'm of the belief that AI in all aspects of it, whether it's engineering or legal or this or that or the other fields, will create so many jobs and opportunities that 5-10 years from now, we're going to be looking to see how we can train more people to get into the game. Because as it is with every massive technology that creates discontinuity, there's always this fear that, jobs are going to go away. We're all going to need to sit on the beach and, have our margaritas. I completely don't believe in that. Now, there is a discontinuity point where these technologies come in and they disrupt. But after that disruption is finished, an opportunity pipeline opens up for all various jobs about how to use that to create something that, customers or people in the community want. And those opportunities, some of them we don't know right now. Some of them are actually kind of evolving. already. Some of them, we had a young member of our friends family that was asking for advice. I've been offered this job to go be an AI um, an AI training specialist, and I don't know whether I should take that job or not. What is an AI training specialist? And when we looked into it, the company was hiring her using her education, which was in finance, to be part of a team that continues to train and make these systems for AI better. We're like, look, this is the future. Here's a job that if you had seen it 3 years ago, you'd have said, what? What is this job for? But there'll be many like that we can't even kind of imagine today. But I think AI ultimately will create a lot of commerce, a lot of comfort for us, I think, and elevation of what people are good at, which is kind of, thinking through things, architecting, identifying market opportunities, doing the hands-on work that, as you said, requires in the lab for people to get the chips and the trains and the computers assembled and working and so on and so forth. And it'll just be more of those.
Everyone listening, replay that answer. That is a very succinct, articulate version of why this important conversation needs to happen. Why when we talk about AI and the future of work, we say that we're on Team Human because we believe in the power of this technology to make humans better. I mean, that example is a microcosm of everything we discuss. 362 of these conversations. It's someone with a finance degree, maybe, looking down the barrel of an accounting job that might be susceptible to automation, being offered an opportunity to use the same skills to be an AI data trainer or whatever the case may be. And every industry, every field has an example like that lurking. I love that answer. Great answer, Faraj. Thank you. So again, I'm going to oversimplify here, but the problem in this kind of Cambrian explosion of need for chips and lack of people to build them that Cognichip seems to be automating is the dearth of intelligence that's going to be available. And I mean, you've just solved a hard problem in a beautiful way. I mean, the tokens are essentially limitless. And so synthetic intelligence will become cheap, and it's a great way to take care of the human skills gap. I would think, though, because of just the need for more and more chips outpacing our ability to design them, which I may or may not be correct in that, there might be other bottlenecks, and I don't know what they are, but I'd love to get your perspective. Is it we're going to run out of sand? We're going to run out of manufacturing capacity? Obviously, we always talk about power. Are there other impediments to being able to satisfy the world's increasing need for chips that come downstream?
Yeah, I mean, there might be. Today, when we look at this, really the human capital to be able to develop, bespoke chips for a lot of different applications that are cost effective, don't waste energy, and can meet the requirement on one hand, I believe is the challenge for our industry. Lack of obviously engineers is driving some of that as well. But if you think about it, just bringing it back to sort of like what all of these technologies enable, and in this particular case for us, have you ever thought why big complex chips in our own country here happen to always be kind of centered around Silicon Valley? The reason for that is that in complex problems, and I use chip just as one example of that, but when you have a complex, multidisciplinary product you're trying to build, you need to be in an environment where all of those types of human skills are available to you and local to you, preferably, right? This is what chip business is. The reason we can do these complex chips is because to do a chip, you need people with lots of different knowledge within the chip, but in their own vertical domain. Now, if you go to Austin or you go to Boston, you go to Nebraska, right? Let's take the last one. as an example, or Boston as an example. Lots of great universities, lots of good people are being graduated from schools like MIT's and Princeton, this and that. But you don't find big chip companies being built there because experienced people with knowledge in multidisciplinary areas are not in one cluster, and the VC industry is not looking to invest in those groups because they just can't expand. So they end up coming here. Now, if we were able to create that knowledge capability within these compute systems, you may find 2 out of 3 of them available for you in Boston, and the other 3 come through these compute systems. And now you can actually form a team in Boston to build that chip that you want to build. You don't necessarily need to be physically sitting here in Silicon Valley and know enough people to recruit from, right? The societal impact of this transportability of expertise and knowledge, to me, is little understood, because great ideas are all over this place, all over this country, all over our university campuses. And the reason you can see software teams coming out of universities with a couple of sophomore juniors is because, the process of them building what they need in the software industry has been around for a long time, right? There's been operating systems, there'll been that helps you build things, and you just add your own thing to it. In the chip business, it's not like that. And if we can turn designing chips into something like this, similar to this, now we're democratizing it. Now great companies can come wherever there is a bunch of people who know what they need to build, have some of the expertise but don't have, convincing investors to invest in them because, hey, I can get to this solution within months, and with certain limited amount of capital. We've now democratized chip design, and we're bringing a lot more fresh ideas on the types of devices that need to be around to enable certain applications that are growing. So to me, my vision is that enabling people with good ideas may not even be, have enough electrical engineers in their team, or frankly, have very few or none, maybe, to be able to imagine a chip, imagine a functionality, imagine an application, and be able to go and build it. And I think these systems have that impact on our society.
Well, related to that, we started talking a little bit about responsible AI, and you referenced the kind of 3 tenets. How do you think about responsible AI, given that what you said is, the human is speaking English to the AI, and it's, they're collaborating. If the AI accelerates or leads to a flaw, a bug, etc., that has some downstream impact, less from a legal or a liability perspective, but more just from an ethical or a company culture perspective. How do you think about the responsibility that Cognichip has to potentially introduce flaws that a human might not catch?
Yeah, so we are actually very focused on that, and I talked a little bit about sort of like we code in the ways human can understand, but we also have put in our system explainability all along the way. So before we go generate some collateral, chip design collateral, we actually lay out a clear plan about what it is that we are going to produce. And then we produce it. And then we make sure that everything that's produced ties to what we said we're going to make, right? And that's visible to the individual. So there is really no kind of black hole kind of concept the way we're approaching it. Trust me is not enough, or trust the machine is not enough. You kind of need to tie pieces together. And if you're asking it to make a change, it needs to explain back to you how it made the change so that you can actually go check it, right? So we built all of these guardrails in there, and frankly, we're thinking about this all the time because, chips, like anything else. So, yeah, as they say, you build a hammer to do a nail, and then the hammer can do more damage. So you have to be careful in how these systems good. So there are agents in our system that are written to constrain, essentially, or give guidelines or give scaffolding to what these compute engines are producing. It's sort of like a limitless, endless process, I believe, to build responsible AI, and everybody has the responsibility to do what they can to make sure that these systems really deliver what we're asking them to deliver and don't get a mind of their own and go off the rails.
Great answer. That's why I shared that in a fun fact in my commentary, because that's what it means to exercise AI responsibly, is hold yourself accountable. And more than that, provide the visibility or the explainability of what the automated decisions did. And that's what we expect from humans. It's also what we should expect from machines.
And they're not hard. By the way, the things you just said are not hard to do. They're actually not only the right way to do it, but it's the preferred way to do it, because people that are using these machines, they need to trust the machines, right? I mean, in our industry, this is an industry that's 50, 60 years old. And in order for them to trust the product that I'm building, they need to be able to relate to it. They need to be able to query it, right? If you're building a company and in AI and you're not paying attention to this, you just put a negative mark next to your product because its adoption may be impacted, right? Particularly in the enterprise and more deep tech areas, because people will ask you these questions.
You say it like it's such a universal truth, but now more than ever, we're all questioning, what is truth? I mean, right? All around. I mean, no, that's a whole tangent we could spend another episode on. But I'm glad that to you it was just almost like a platitude, like of course, and yet so many other facets of our lives, we're actually having to ask the question, what is truth?
Yeah, very true.
And I will put a pin in that, and would love to just continue this conversation. But for now, I got to get you off the hot seat. But you're not going anywhere without answering one last important question for me.
Sure.
I mean, here we have, really just the legend. I shared your background, going back to 97 and Centillium and 3 years to an IPO. And then I know we haven't talked about it, but you also spent a decade as an investor. What would the Cognichip version of Faraj tell the Centillium version of Faraj about entrepreneurship and maybe what's ahead? What would your coaching be to that version of Faraj?
Oh, wow. So, first of all, I'm a fundamental believer that luck has a lot to do with every one of our success. I truly believe that. And it has been true throughout my whole life, whether it's professional or personal. And always believe that. I think that attention to the team you build as an entrepreneur is critical, and it's critical in lots of different ways. But as you're building the team, complementary skills of the management should be your number one priority. Of course, they need to be intelligent, obviously, but complementary. You don't want to build a team that's a carbon copy of each other, right? Because those blind spots come glaring when the world isn't treating you the way it should. Centillium was an amazing success for us, for our investors, for us, for employees. It was fantastic. But every company have ups and downs. And I learned a lot more about running a business in its doldrums than it was in its glory. Because that's when every little problem gets magnified. Whereas when you're running fast and success is just every day happening after, it suppresses. You don't see them. You don't see those imperfections that you got to work on. So, yeah, attention to detail, build a complementary team, and making sure that you have a personal relationship with the people in your company. As a startup, that's critical, right? So all of that have culminated into a culture that I'm pushing in our new company. Things like, question everything. You need to, as an employee And as a member of the team in the startup, question every decision. You should be asking why. At the same time, follow that up with, why are we doing it this way when we can do it this other way, right? And just that questioning, everything has to go up and down the chain. It doesn't matter who you are in that company. You should be open to that. In our culture, we want everybody to ask questions, from me, from other co-founders and leaders, but do it in a respectful, do it in in essentially a loving way, because you care about the people you work with and you want them to do better. So those types of things I've learned over time, and as I go along in my career, and I get older, like you said, put a pin on them and you double click on it every once in a while to make sure that not only you but people around you are kind of benefiting from that.
Amazing journey. Just good insights.
Thank you.
Where can the audience learn more about you and Cognichip?
Well, we have a website. It's cognichip.ai. We talk about our vision there. We talk about our industry. We've written a few blogs. Myself, I've written some of them about the challenges in this industry. And we'll continue to add to that in sharing our experience as we roll out products and build this amazing technology.
Brilliant.
Reach out to us.
Faraj, humanity is rooting for you to succeed. I wish you all the best, all right? And please take me up on the offer. Come back sometime and we'll continue the conversation.
Thank you, Dan. I've enjoyed it anytime.
Excellent. Well, gosh, that is all the time we have for this week on AI and the future of work. As always, I'm your host, Dan Turchin from PeopleRain. And of course, we're back next week with another fascinating guest.